So my name is Rick Nelson, and I manage the pre-sales team at NGINX, and I also have a team of engineers who work on integrating NGINX with various platforms, so we know how we work with, again, the Kubernetes, Docker, and all the various things that are coming out there. So the latest version of Docker, version 1.12, was released in late July. I don't know how many of you had a chance to play with it, but they've integrated Docker Engine and Docker Swarm. So now it creates more of a full-fledged platform, something like Kubernetes, for example. So we've been spending time here at NGINX working with this new version and seeing how NGINX open source and NGINX Plus and integrate with it and add a more advanced load balancing solution. Okay. So I'm going to start out by talking a little bit about Docker Swarm and these new features, and I'll show a demo of that. And then I'm going to talk about how you could integrate NGINX open source into that, which I'll also demonstrate. And I'll also talk about NGINX Plus, our commercial version, and how that can provide an even better solution, and a demo of that as well. And I'll finish by talking a little bit about how load balancing can work in a microservice architecture and how that relates back to the examples I was showing you guys. So talking about Docker, Docker Swarm has been around for a while. It lets you create a cluster of Docker hosts, and then you can schedule containers across those hosts. With the new Docker and something called Swarm mode, again, where they've combined Engine, and Swarm, you can now create a fault-tolerant, self-healing, and decentralized architecture. It's also easier to create your Swarm cluster, and also each node is identified by a key, and all the communications between nodes is done over TLS. And one of the big additions is to the API, they've added the concept of services. So a service is a set of containers that run the same image. They're kind of like Docker services in Docker Compose, but they have more features. And you can scale services up and down. You can do rolling updates. You can set up health checks and things like that. You can also now set up cluster-wide overlay networks. It also supports DNS service discovery that's built in along with load balancing. And I'm going to show all of these things in my demos today. So a quick look at the architecture of Swarm and how I'm going to do it. I'll start with this is how my first demo is looking. So I've got 3 nodes. I've got a master and 2 workers. All my commands I'll be running on the master. And then Swarm's going to handle all the scheduling of containers. And for my first demos, it's going to handle all the load balancing, and we'll also be using the service discovery. Now, when you want to do private networking within your cluster and your containers, you can now do these overlay networks. And I'll be showing that in my demo as well. And you can expose your services to the external network via the Swarm load balancer. So with the Swarm load balancer, it can handle both the external communications, and it also can handle all the internal service-to-service communications. So let's take a look at the Swarm demo. Now, in the just for full disclosure, if you watch my demo, you're going to think I'm an amazing typist because I make no errors. But I've scripted all my commands. There's a pretty cool tool I found on GitHub, which you'll see when I post my stuff to GitHub. But it actually types all the commands, so they're real-life commands, but I don't have to type them, and you guys watch me make all the mistakes that I would normally make. So here, didn't work. Oh, I see I'm on the wrong tab, pardon me. Actually, let's go in. Can you guys see that, or is that too small? Okay. Sorry, it's got a little crazy here. Okay, let's look at our cluster. So you see the 3 nodes that I mentioned, and I showed in the diagram. So there's the master and the 2 workers. And what we're going to do is we're going to create a new service for a back-end app. This is using an image called Hello, and it's a very basic web app. It just displays an HTML page that lists some information about itself, like its IP address, for example. That's the one we're going to be looking at later on. We're going to name the service backend app Swarm, and we tell Docker that we want to expose port 80 on the containers as port 8085 on the host. And what that's going to do, because we're not doing any other networking stuff, is the Swarm load balancer is going to create a virtual IP address listening on port 8085, and any traffic it gets to 85, it will then load balance across all the containers. And here I've asked for 3 containers or replicas. And we can see that we've created our service by doing a service ls command, and we see that there's our service, and we have all 3 replicas were created. If we had an error, you might see 2 out of 3 or something, but in this case, we see that they're all created. And we can see where they were put by running the service ps command. And we'll see I have 3 nodes. I started 3 containers, so it's not a surprise that they're spread evenly across the cluster. And if we want to see, there's the standard docker ps command to see the one that's running on the master. Okay. Now to scale a service, you use the service scale command, and you give the name of the service and then how many containers you want. Again, or replicas in the more proper terminology. So I asked for 3 before. Now I can say 5. And again, have it very quickly. And if I now take a look at the docker service ps command, I'll see that I now have 5 spread across there. Again, pretty quick, pretty easy. And now I can curl that port 885. Again, that's the one I exposed externally. And I should see that this IP address will change to the 5 different ones. And it's not. So there is still a few flaky things with the Docker networking. I'm using version 12.1, which is, they improved a lot of that, but I still occasionally see these little things here, which I'm not going to try to investigate now. Rebooting clears everything up, but we'll see that later. Anyway, I can clean my demo up by just removing that service. So I just do service remove. And now if we look, we'll see that the service is gone. Let's hope our other demos go a little bit better. So you may be asking, now that Swarm has load balancing built in, why would I want another load balancer? Well, the Swarm load balancer is a very basic layer 4 TCP load balancer. And you may need to do things like SSL termination, content-based routing. For example, you may want to route based on the URL or a header. Again, you may have access control or authorization needs, rewrites, redirects, that sort of thing. Now, one of the load balancers you could use with Swarm is NGINX open source. In addition to the features I mentioned before, it also adds things like more advanced load balancing algorithms, more protocols, WebSocket, HTTP2, for example. You have configurable access logging. You can do traffic shaping, so you can limit the connections, the request rate, the bandwidth, that sort of thing. You can also script more advanced use cases. So today you can use Lua and Perl, and we just have released NGINX, the latest version of NGINX, so you can do JavaScript as well. And advanced security. It can be as simple as whitelist and blacklist, or we've also just announced that there's a mod security available, a native module for mod security available for NGINX, so you can get a lot more security out of that. So how would I fit NGINX into this picture? So I actually want to spin up NGINX open source as a service. I'm going to put it behind the Swarm load balancer. Because that's the way it's easiest to expose the IP address on the external network, and it allows me to have my NGINX open source images as a highly available set of nodes by putting it behind the Swarm load balancer. It's really simple to do that. So now I'm going to spin up my services. I have a service A here that I've spun across 2 nodes in a cluster and 3 of them. When I spin up NGINX open source, I'm going to do it just like I did in my last demo. I'm going to basically say I want to expose it. I want the Swarm load balancer to listen on a virtual IP address and handle that to the open source. I'm going to do the same thing with the backends, just like I did last time. I want the Swarm load balancer to handle them. And the reason I'm not having open source talk directly to the backends has to do with scaling. If I were to put the actual IP addresses of those backends into NGINX open source, every time I scaled, I'd have to reconfigure NGINX. If I have the Swarm load balancer do it, then I get scaling automatically, and I just need to have NGINX resolve the domain name of the service, because that resolves to the VIP, and all the scaling happens automatically for me. And so you get something like this. So the client makes a request, hits a Swarm load balancer, it goes to NGINX open source, which then routes the request. And for internal service requests, I'm letting Swarm handle it completely. So NGINX is only handling the external, so just on the edge. Now I could actually I could go directly to the backends and remove that arrow that goes basically NGINX open source to Swarm load balancer to the backends. But again, that requires a much more complex configuration that I have to reload NGINX. We'll see in a minute with NGINX Plus, this actually becomes very easy, but with open source, it requires a much more complex configuration with things like console, templating, and that sort of thing. So now let's see a demo of using open source. So for this demo, I'm going to create an overlay network between the NGINX open source and the backend containers. So I give it a name, and we can see that it was created by doing a network list, and you'll see it at the very top there. And now I'm going to create a backend service again, and it's very similar to what I created last time. I'm using exactly the same image. The only difference is I've added this network, app network, so that I want it to listen on the this overlay network. And we can see it's been created just like last time. However, there is a, sometimes there's a delay here, but let me see if the, actually, go back here. There's actually a delay or if it's actually not working. It's up now, so there was just a delay there for it taking a while there, so not go there. And again, we can see again they've been distributed across the back ends. Now we're creating the NGINX open source image, and you see it's pretty much the same as I created the back end image, except I'm exposing port 8090. Last time you remember I was doing 8085. Now it's 8090, but I'm also exposing the HTTPS. So I'm taking 443 and exposing it as 9443. Because for the reason I'm using NGINX open source in this demo is that I can now do SSL offloading that Swarm Load Balancer can't do. Again, now we see we have two services. Again, 3 containers of the backend service and 1 of NGINX, which again, I'm using a very basic image here. Again, my diagram showed multiples, but to keep things simple, I'm just using 1 NGINX here. Let's see if it load balance. Now we should be load balancing across 3 backend containers, and it's not working. So it's timeout here. I'm going to just reboot my machine, and then we'll get back here. So, okay, so I think I was the next stage here, but we're going to create the overlay network. And we'll see that it's there. Let's go through this quickly. Create our backend service again. See that they've been created. They've been spread across the nodes. Now we're going to create NGINX open source. Okay, again, it's probably just a delay, so let's see if we can curl our back end this time. There we go. Okay. So we should see it's changed to 3 different IP addresses. So it's scaling there, just as we expected. I can also hit HTTPS now. Again, the back ends are all on port 80, but I've just added SSL offload, so we'll see now we're going back there. And again, you'll see the back ends are still 80, but we hit it on the front on HTTPS. If you look at NGINX configuration, we'll see it's a very simple configuration. I've defined 1 upstream, and I've told it to resolve backend app as the domain name. That matches the service name, and that's how the service discovery works in the new Docker. Again, listening on ports 80 and 443, I got my self-signed search there, and then just doing a proxy pass to the backend. So very simple configuration. Again, I set this up, and I was able to scale them up without having to touch the configuration or do any reloads to it. And now we can scale the back ends, again, without touching the configuration. And now if we should see that we load balance. Well, there's a 5 container, sorry. Now we can see, we should see the IP address change 5 times now. And it does. So the new containers are being used, and we didn't have to touch anything. We can clean this up very quickly by removing the service, the NGINX service, the backend service. And I'm also going to remove this overlay network. And I'm just going to mention this because you'll see in a minute I'm going to create it again. And I found there's a little flaky thing. If I leave it around, I have some networking issues, but if I remove it and recreate it, then everything works fine. So removing that. Let me find my place in these. How do I get presenter mode to go over here? Sorry, again. Okay. Thank you. So I assume that since you've all come to an NGINX conference, you're pretty familiar with the open source product, but you may or may not be that familiar with NGINX Plus, which is the supported commercial version. So I'm going to just go over very briefly, just for those of you who don't know too much about it. So it's based on the open source code, but it adds some new features, mostly around load balancing. Again, so we can make an enterprise-ready ADC out of it. So this diagram is trying to give a high-level view of sort of what's in open source, what's in NGINX Plus, and where the dividing line is. It may make it look like half the features are in open source and half in Plus, but that's not at all accurate. The vast majority of the features are still in the open source, with just a few very powerful, but not a large quantity of new features added into NGINX Plus. So the main features are active health checks, where NGINX will continue to check the back-end nodes, not only that they're up, but they're actually responding correctly. So you can do actually pretty detailed health checks, and I'll show you in my next demo, how you can do more advanced health checks. And also session persistence or sticky sessions. If you have stateful applications and you need to make sure that when the client gets back to one backend, it needs to stay on that backend, that's supported. And then also session draining. Once you have sessions in flow, if you want to take a server offline that has sessions, you need a way of dealing with that, and that's one of the features that we have here. And very importantly to using microservices and containers is the ability to dynamically configure your backends without having to configure and reload NGINX. So that's one of the features, big features of NGINX Plus, and it's one of the key features when you're trying to integrate in a microservices environment. Makes your life a lot easier. And there's two ways of doing it in NGINX Plus. We have an API, so we have a push method. You push the changes to NGINX with an HTTP request. And then we also have a pull method where NGINX will re-resolve DNS. You remember my last demo, I showed how NGINX Plus, open source, was just using a resolution of that name, but open source just does a resolution once. And just open source, you can tell it to keep checking. And the way service discovery works in Swarm and other platforms is that domain name resolves to the IP addresses in the back ends, and it adds them in there, adds and removes them there, and by doing the re-resolution, will be updated automatically with that. And we also have live activity monitoring. This is based on an API that gets you a wealth of metrics out of NGINX Plus, and then a dashboard that is built on top of that API, again, that gives you a lot of the metrics on the instance. And you can also add or remove nodes and make changes to nodes on this as well. Now, just to go back and remind you a bit with my open source demo, when NGINX open source wanted to talk to a back end, it went through the Swarm load balancer. And that was because I didn't want to have to reload every time it needed to do scaling. With NGINX Plus, because of the ability to do the service discovery, we can now talk directly to the back ends. And again, I'll demo that in a minute. We don't need the load balancer here. We still have the Swarm load balancer in front of NGINX Plus, and again, that gives us a really easy, high availability solution there, very, very easily and cheaply. But in the back end, we don't actually need that or want that, so we take out the Swarm load balancer there. So the architecture of my NGINX Plus demo, and I have two here, I'll start with one. I have two services. The idea here is I'm trying to demo an external service, which is service 1, and an internal service, which is service 2. Although it's actually available externally, so I can show it to you. But the idea is that a client would call service 1, and service 1 calls service 2. And they're very basic. Service 1 is effectively the same service that I was showing in the previous one, but it's a PHP page, and it makes an additional call to service 2. And service 2 is very similar, it just returns some information, but does it in JSON format. So it's an API request. Again, the Swarm Service API is what scales them up and down. It updates DNS, and then NGINX gets updated because it's checking DNS. So that's how that sort of forms a whole loop there. All right, so this is part 1, so we'll show that. Okay. So I said I'm going to recreate the network I just deleted because that keeps things clean, and it seems to work that way. Now I'm going to create my backend service, service 1 first. And if you look, it's very similar to how I created the backend service in my last demo, with one exception. That's that -- endpoint mode DNSRR. And that's really key here. We were using the default setting last time, and the default setting is to tell Swarm to create a single virtual IP address and load balance the backend. So anybody making a DNS request on that backend will get one IP, and it's the Swarm load balancer IP. When you say DNSRR, which is DNS round robin, that tells Swarm load balance, basically don't set the load balancer, and anybody making a DNS request for service 1, in this case, will get all the IPs back. And that's what we're going to use. That's how NGINX can get that in there. Other than that, you'll see it's very similar. Same overlay network, 3 replicas, and so forth. Now we'll create service 2, which is going to look exactly the same. Again, service 1 and service 2 are simple images that are NGINX and PHP FBM, and they each serve a single PHP page. So I'm also going to create an etcd service, and this is something I added just so it gives me a way of triggering health check failures on back-end nodes for my demo. And I'll explain a little bit more later on how that's working. And finally, we're going to create our NGINX Plus service. Again, I'm going to do one. In a real-life situation, you would do more, but I'm keeping it very simple here. Again, so I'm exposing 80 and 443 as 80 and 443 on the externally. But I've added 2 more. 8081, that's our status API. Right? That's where our status API I've configured to listen on. And then 2379 is actually for the etcd. So I'm load balancing that as well. Okay. And we can see there's our services. And we can kind of go through each one of them. And you'll see I got 3 of service 1 spread out, and service 2. etcd has just a single one. Again, for my case, it's very simple. And we have one in NGINX Plus as well. Actually, before I want to scale, let's go to look at the dashboard. I guess I have to move over here. Let's actually move this a little over here. I'm sure you guys can see. So right now, so that's actually. So there's our dashboard. And we see the 3 service 1s that we just showed, the 3 service 2s, and my 1 etcd. You'll see there's no traffic coming here. But you will see there's traffic here, and they're all 400 errors. It looks like a bad thing. In this case, that's actually a good thing. The health checks that are happening on service 1, which I'll explain in a minute, are actually making a call to etcd and looking at their IP address. If they find a hit, they say, oh, I'm going to mark myself down. So it's kind of opposite of how a real health check would work, but I'm just trying to demonstrate here. So those are the health checks, and the 404 means that it couldn't find a record of itself in the etcd. But again, I'll explain the health check a little more when I show the configuration. Now if we go back here and scale the services, and we're scaling both service 1 and service 2, I want to scale them equally because service 1, every time you make a call to service 1, it calls service 2. So they're always going to be equal there. We should see, easy around within 5 seconds or so, we should see, there they go. So we've now added here. Again, we haven't touched any configuration at all. That was happened because NGINX Plus re-resolved and found the new things there. So we can show you what service 2 looks like really quickly. It's the simplest one. There it goes. It's just a JSON response that just returns, again, its name, the URL, and the IP address. And then service 1, returns information about itself at the top, and then at the bottom makes a call to service 2. And if we refresh this, we'll see the IP addresses change in both because they're both getting separately load balanced across the 5 ones in the back. So we can take a look at the engine configuration. It's a little bit longer than the one we saw before. So at the top there, we have to define the DNS server. That's the resolver. And that's the address of the local Swarm DNS server. And that valid 1 second tells NGINX that any time that I ask it to re-resolve, it's going to re-resolve 1 second intervals. And I've set this globally. You could have this at any layer, but I've set it globally. I've got my service 1, service 2, and etcd upstreams. And I've told them all to re-resolve, and that's what that resolve parameter is. That's an NGINX Plus feature. But again, you'll see I'm doing these services all in their names because that's what the DNS domain name is. And you'll see that zone. That zone directive is an NGINX Plus thing that basically gathers it's a shared memory area to gather statistics, and also where the dynamic configuration stuff is stored. So those match blocks are for my health checks. So in both cases, I'm looking for a particular string when I do a health check. And I've tried to simulate 2 kinds of very common health checks. One is, on service 1, is customers write a backend app in PHP or something, some page that basically does a database lookup, checks the, does a app server read or something, says, hey, I'm okay. That's what that's simulating. And that's the one I'm using etcd. So in my case, I'm doing an etcd lookup. It's kind of backwards because I want it to default to being up. So it looks and says, do I find my IP address? If I don't, I'm up. If I do find it, I'm down. And I have a simple script that just sets the IP address into etcd, and it reads that way. The second one, service 2, I don't have any special page. I'm actually making a call to the service 2 PHP page, which is the normal page, but I'm making sure the beginning looks like the proper JSON response, the part that is static, because the rest after that is dynamic. And then we've got our listen. That part is actually similar to what we had before at the top. That status zone directive tells NGINX to collect stats on the server zone, and they appear on the dashboard we just saw. And I've got my locations. So the default location I have going to service 1. Again, service 2 goes to the service 2 service. And I've made special health check locations, not required, but it's kind of a good best practice. And you see I've got etcd listing on my other port there. So, and then there's my status dashboard. And I've also done our upstream configuration API. I talked about that push API. I'm not using the demo, but that's how you can configure that there. Not sure what I did there. Hold on. Bear with me again. Okay, so that's it for that part of the demo. Okay, so let's make this demo a little more interesting. So I have a Python program that uses the status API I talked about, and it calculates the requests per second per healthy node, and it tries to keep it in a range. If it sees that it's fallen below that range, it wants to scale down. If it goes above that range, it wants to scale up. So if it wants to do a scaling event, it calls the service API, and it says the commands you saw that me run manually, it basically says add or remove containers. And then that updates DNS, and then it updates NGINX. Again, I've done some things that's looking for healthy nodes, so if a node's down, it won't calculate into there. And I have a range, like I want a minimum of 2, maximum of 10. It'll add 1 or 2 at a time, remove 1 or 2 at a time, that kind of thing. So let's show that. So I've got a few other shells here. So first we're going to run some load. So this is a program I'm using Siege for load generation, and it just randomly generates a duration and an amount of load. And if we come over here to our dashboard, we should see some load going on. And you should see load go up and down over time. So if I run my Python program, called autoscale. So it defaults to, if I don't give it any parameters, it starts autoscaling service 1. I want to autoscale both services. So I'll autoscale service 1 on this page. If I could spell it correctly. This is why I try to script stuff. And then here we'll go and autoscale service 2. And now if we watch this, we should see that the nodes are going up. You'll see them going up and down. There is a delay. It takes a while for Swarm to sort of get them up there, so I have it waiting every 5 seconds. But we'll see it go up and down based on load, and again, there's a bit of a lag there. I know I'm running out of time here. So real quickly, I just want to show, again, the health checks. As I said, one of them I'm trying to simulate actually checking the system, and I'm using the etcd. So I can come in here, and I have a script called set_err. And I just add in the last octet. So actually some are going down by themselves occasionally. But if I want to do, say, that number 12, I do that because the script knows they're all 10-0-0. It's going to write a record etcd. It's going to wait a second. You'll see the next time the health check fires, it says, hey, I do have a record now. And we can fix that very quickly as well by removing the key in etcd. And we'll see within a second or so it cleans up there. So I think we're almost out of time, if we're not already out of time, so let me quickly go through the last part here. So how many of you attended the keynote this morning, Chris Sesson's keynote about the different models of load balancing? Fair number. So I'm going to go, again, I'm running out of time because of my demo issues. I'm going to go through it much briefer than he did, but if you watch the recording of that, if you notice in my demos, I'm actually using my load balancer differently in my different configurations. So I want to talk briefly about that, the different load balancing methods. And again, this is what Chris went into much more in the keynote today. When you go from a monolith to a microservice environment, you're moving to a bunch of distributed independent services that can all be scaled separately, and so load balancing becomes a much bigger deal. I have a lot more load balancing to do. So the proxy model is the simplest one, where you have NGINX or NGINX Plus sitting on the edge, taking the incoming traffic and load balancing to the back ends, but it's not worried about service-service communication. And that's what I did with my initial demo with NGINX open source, was basically doing that. Even though the Swarm was in front there, was really handling them and going back there, but Swarm was handling all the internal requests. So that was an example of the proxy model. Again, because Swarm was handling the internals. The router mesh puts NGINX in the middle as well, so it handles both external and internal communication. And that's what I demonstrated, just my NGINX Plus demo was doing that, because I was handling both external and internal. So that was a router mesh demonstration. My very first demo of all Swarm was also router mesh, because Swarm was handling everything there. The most interesting one is the fabric model, and then this is one that Chris was pushing. And the reason this is so important is if you go to an SSL everywhere architecture, the last two are actually the simpler ones, but if you go to an SSL everywhere architecture where you're do internal communications or SSL, you're going to see some performance hits because you have a lot of handshakes going on. And the reason you have these handshakes going on is because almost all to my knowledge, maybe there's some exceptions, application libraries don't do a session reuse. So when they do a connection, they establish it, very expensive, they tear it down every time. That's a very inefficient way of doing it. The fabric model actually puts NGINX in every single container, which you can do because NGINX is such lightweight, has such a small footprint. And it works as a forward and a reverse proxy. So all the communications handled by NGINX Plus, and it does keep alive connections, so it's not doing all that reuse. It's NGINX Plus here and not open source because you're ruining the dynamic service discovery to make this work. So that's why that's there. So then we talked a bit about some of the new features in 1.12 and showed some of their power there. I've talked about how open source can fit into that, give you some more advanced load balancing, how NGINX Plus gets you even more in there. So I hope you guys found this useful. My apologies for the demo hiccup in the beginning. That always seems to happen sometimes. We have basically a short time for questions if anybody has any. Great, thank you everybody for coming. And everything will be on GitHub, and the recording will be out there. The presentation will be, I'm not sure wherever you put that. And I have some links in the end here that links to some stuff. All right, thank you. If you guys we have a booth over there. If you have any questions you want to see us in or ask any questions. Thank you very much.